Okay, class, I'm here to go over the textbook pages from today's lesson. So if you look at number one, okay, it says find the volume of each rectangular prism. So you just do base time, length times width times height, or find the area of the base, then multiply that by the height. So since number one is a cube, 3 times 3 times 3 is 27 cubic inches. Again, really make sure, guys, you write the units in there. For number two, base times height. So the area of the base is 6 times 2, length times width. Multiply by the height, you get 36. Number three is 14, 2 times 1 times 7. And 4 is 3 times 2 times 5. All right, so pretty straightforward, I would think, right? Length times width times height. Find the volume of each. Okay, number 7 here. Same thing, base times height. So what they're showing you here is how length times width times height ties into that formula base times height that I talked about in the lesson. So you can see the base is 6 because 3 times 2 is 6. And you notice that's squared inches because it's the area. Then you multiply that by the height, which is 4, and you get 24 cubic inches. All right, so number 8, just do 7 times 2, which is 14. The area of the base, multiply that by the height, you get 42. 9 is 36 square feet because 3 times 2 times 6 is 36. And 7, 343 cubic centimeters because length times width times height is that. All right, so now we'll get into some little bit more difficult problems here. So I'm just going to scroll down. So with number 11, 12, and 13, okay, what you need to do is use inverse operation to solve for the variable. So you write the formula, volume equals length times width times height. So you write 56 equals 4 times 7 times 2. Okay, and then what we do is we're going to be multiplying 4 times 7. So what you end up having is 56 equals 28 times x, or whatever you put the variable in for height. Then you use the inverse operation, divide both sides by 28, which is the inverse operation, and you get 2. All right, so number 12 is 144 equals L times 9 times 4. 9 times 4 is 36. Divide both sides by 36, and you get 4 feet. Number 13 is 240 equals 8 times a variable, which you can use W, times 6. 8 times 6, you divide both sides by 48. All right, so I can see this being confusing, so please let me know if you want me to show a video explaining this a little bit further. I'd be happy to do so for you guys. Okay, I'm just going to scroll down a little bit. All right, so number 14 is just like that last question that I showed you in today's lesson. So in today's lesson, at the very end, I showed you converting to a cubic foot, right? So this is the same problem, right? Because it's 1 by 1 by 1, but you convert it before you compute. So 12 times 12 times 12 is 1,728 cubic inches. All right, number 15 is you just multiply. So 4 times 3 is 12. 12 times 10 is 120. So 120 cubic centimeters. So it's saying, is that enough? The answer is no, because we need 150 cubic centimeters of sand, and we only have 120 cubic centimeters. Number 16 is, it's kind of a tough question because I introduced it to you as LWH and then went into base times height. So this is like kind of going backwards. They're like, well, if you have base times height, how do you get LWH? Well, because L times W is the base. That's what they're getting at. Number 17, which of these equations gives you the volume of the cube? So the reason why 16 times 4 is how you can find the volume of a cube. They get 16 because the length times the width is 4. So if that's the case, if the length and the width are 4 and the height is 4, that means all the dimensions are the same. Okay, C doesn't work because it would be 3 times 4, right? Length times height, right? And B doesn't work. I think they were trying to I'm not sure what they were going at with that. Maybe like 2 times 2 times 2 times 2. And neither neither does D. So the answer is A. All the dimensions would be the same, 4 times 4 times 4. Number 18, suppose the blocks of ice used to build the room of the ice hotel are 4 feet by 4 feet by 5 feet. What is the volume? So they show the visual to the right. So 4 times 5 times 4, or 4 times 4 times 5, doesn't matter the order due to the commutative property, is 80 cubic feet. Okay, I'm going to scroll down a little bit further. All right, so consider a rectangular prism measured 3 by 2 by 6. Will the actual volume of the rectangular prism change if the measures of the sides in inches rather than centimeters? So you think about it, the answer is no. The numbers are going to look different, but the units are going to be, the numbers will look different because the units are different, but the volume, it's still the same size. It's not changing the size because you change the unit. So on the below it says no, the volume remains the same because the size of the prism does not change. So B says, does the numerical volume change if you measure the sides in inches? I can understand being a little bit confusing on the wording of that. So what they were getting at, right, is the numbers. Will the numbers change? Well, yeah, the numbers would change, but the size won't. So part B, if you look on the bottom, it says, yes, the number of cubic inches will be smaller because cubic inches are larger than cubic centimeters. So just the units change. All right, so again, let me know if you guys want me to go over anything particularly. Numbers 11, 12, and 13 if you're having any troubles with that. All right.